Okay, so on the back we have a couple of other examples. This one still wants us to write the equation of the tangent line, but of course this one looks a little more difficult. We just need to use all of our rules that we learned back in pre-cal to make this a function so that everything's in the numerator and we can use our power rule. So let's go ahead and find our y value first. So we're going to plug in our 8. So 1 over 2 times the cube root of 8 squared. Oh, sorry. That's the cube root. Oh, yeah, that'll work. That'll work. The cube root of 8 squared. So the cube root of 8 would be 2. 2 squared would be 4. So I'll have 1 over 2 times 4, or 1/8. Okay. Now we want to rewrite this thing so that we can take the derivative of it. So we're going to use this 1/2 like I did on one of the examples on the front side. It's just 1/2. And then this whole thing I can move up as long as I change this to a fractional exponent. So this would be x to the 2/3 power. Remember, the exponent goes on the top, the root goes on the bottom, and if I want to bring it to the top, it would be x to the negative 2/3 power. So once I have it rewritten, I can use my derivative rules. So the derivative there, I'm going to bring this times the 1/2. So 1/2 times negative 2/3 would be negative 2/6 x to the, and then we're subtracting 1. So negative 2/3 minus 1, or negative 2/3 minus 3/3. You're going to get pretty good at this because we're going to do it a lot. But that would be negative 5/3. So we have x to the negative 5/3 power. Okay, so now we want to try to put that back into some kind of fraction form. So I know that this negative 2/6 will reduce to negative 1/3. And then this is negative as well. So this whole thing as a negative exponent moves to the bottom. So it's going to be x to the 5/3 power in the denominator. Now, if you want to go ahead and put that as a root, you can. We're going to go ahead and plug in our value so we can find our slope. So I'm going to plug in my 8. So I have negative 1 over 3 times 8 to the 5/3 power, or negative 1 over 3 times the cube root of 8 to the 5th power. So the cube root of 8 again is 2. So we have times 2 to the 5th power, and 2 to the 5th power. Let's see again. I got let's see, what would that be? 32 times 3 is 96. I think I got that right. So negative 1 over 96. There's our slope. Here's our x. Here's our y value. And so we have y minus y equals the slope times x minus x. So a lot more fraction work in that problem, but the rules stay the same. So we want to be sure we can rewrite these with fractional exponents. Anything that's in the denominator, we want to move up to the numerator so we can use our power rule. And then don't forget, when you're subtracting, you have to have a common denominator and then combine numerators. All right, one more example. This one says determine the point, if any, at which this function has a horizontal tangent line. Okay, well, let's talk about this horizontal tangent line first. A horizontal tangent line is talking about where the slope of the derivative is a horizontal line. The slope of our derivative is 0. So this is just saying, is there a place where the derivative is 0? And this is going to come up a lot from now until the end of the year. So when you see things like that, you've got to be able to interpret what they mean. So let that sink in for a minute. The horizontal tangent line. If I had a function, an original function that had a horizontal tangent line, it would be at one of the places like this, where the derivative or the slope is 0. Okay, so we know what we want to do. We want to try to figure out if there's a place where our derivative equals 0. So we're going to need to, I'm first going to factor this out and simplify it a little bit. We can pull an x out of this numerator. And when I do that, this reduces. So that makes finding the derivative a whole lot easier. I don't have this to work with anymore. So I can use my power rule on this function. So I'm going to bring the 2 down times 2. It's going to be x to the first power minus 3, and this is x to the 0 power, so it's gone, and this is 0 derivative as well. So we just get 4x minus 3 is our derivative. We want to know, is there a place where that derivative equals 0, or where 4x minus 3 equals 0? So we're just going to solve that equation. 4x equals 3, divide by 4, and x is 3/4. So on this function, when x is 3/4, we have a horizontal tangent line. Now, if you want to know the point at which, like if this one says a point, it doesn't say just find the x value, it says find the point, then we want to go ahead and plug this back into the original function and see what our y value is as well. Now, since this had a hole at 0, because these divided out, 3/4 is not at our hole, so we could just as easily plug into the reduced form equation as we can this one. So let's use the reduced form equation and plug in 3/4. So we have 2 times 3/4 squared minus 3 times 3/4 plus 1. So we have 2 times, and then square that, it's going to be 9/16 minus 9/4 plus 1. So 18/16 minus 9/4 plus 1. And so I could, well, I guess let's go ahead and just change all these to 16ths. 18/16 multiply by 4, so we have 36/16 plus, and then this one 16/16. So we have negative 18/16 plus 16/16. So we get negative 2/16, or negative 1/8. So here's our x, here's our y. So the point would be 3/4, negative 1/8. That's where this function has a horizontal tangent line.